Europeans also some of the sensors are developed, and we use the electromagnetic spectrum in different purposes and to sense and get the information on the art object. So this is the hyperspectral curve of different types of art objects like vegetation, soil, water, again strictly case soil based on the reflectance properties of the soils. Then atmospheric windows are important. When the light is reflected from the surface, the atmospheric windows are provide us where that light will pass and which light will absorb. So this information is kept in mind while sensors are being built. So this is the orbit of the polar orbit where satellites rotate on the polar, all the poles of the Earth. When the Earth rotates east to west, satellite rotates up and down, and then it can cover whole Earth. But in case of the geostationary satellite, this is around 6 to 800 kilometers. But in case of geostationary satellite, it is around 36,000 kilometers, and it will focus in one disk only. And Earth will move, the satellite will move in the same speed, and it will provide the information. So there are different types of satellites are there. We have the land and water resource management satellites, and the information which we get is used in these categories. Then weather and climate, we insert mostly the satellites which are placed in the geostationary orbit are used for the weather measurement purpose. And then there are oceanographic satellites which provides us the information about the ocean. There are different types of meteorological satellites that have been launched over the time, and this is the geo orbit, which I have already discussed with you, and this is LEO orbit, means low Earth orbit. This is the satellites which are called the remote sensing satellites. Now, there are different types of satellites. I will not go there because it will take a lot of time to explain. But as an overview, the satellite takes the picture, and based on the camera, its swath and PhD makes its resolution. Means two objects can be differentiated if they are a certain distance. It is placed apart. It is placed apart by a certain distance. If it comes in closer, then that object will not differentiate. So, what is the minimum distance between the two objects the satellite sensor can detect is called the resolution. This is called the initial resolution. There are different types of resolution: radiometric resolution, 10 feet, 8 feet. That is called the radiometric resolution. Then spectral resolution is there. That is the band. What is the in nanometer range? What is the width of the band? That will provide the spectral resolution. So these are the different types of resolution, and based on the swath, the amount of area the satellite will scan at a time, it will provide us that information. So based on the requirement, different types of satellites are made, different types of sensors are made, and those are used for different types of mapping and imagery. And so this is resource that we create. This is being launched, and very high resolution satellites having 20 meter this GSD, and 10 meter in some other band. So there are two bands are there, two sensors are there, and two sensors having different types of resolutions. And one GSAT satellite, GISAT, it is launched in geostationary stationary orbit, but it will be used for not for the communication, for the remote sensing purpose, because it will take the image very frequently, maybe half an hour interval. So these are the different types. OceanSat 3A will also go into the orbit, and this will have the 360-meter resolution, and it has the microwave sensors called the scatterometer, which will provide us the information of the ocean and current ocean waves. Now I will just show how the satellite sensor makes this. So now different types of array are there. To take the picture from the Earth surface, it is area array, push chrome, then push chrome, then step and share. These are the different types of methods which satellite human sensor uses to take the picture from the Earth surface. And we generate the false color composite. Whosoever has worked with the remote sensing data, they know that false color composite is nothing but to take into account that infrared portion of the electromagnetic spectrum in considerations, because the infrared portions of the electromagnetic spectrum provide the information of the verifications. So the filters are used to take into account that infrared goes to red, red goes to green, and green goes to blue. So like that, the bands are replaced and the image is created where reds are all the information part. So some of the examples I will just go through about the remote sensing. How there are in agriculture there are a number of applications using the satellite data, crop monitoring, crop intensification, watershed monitoring, drought assessment, and so on. In watershed development also, the locations of the check dams, rust waterways, all are important using the satellite data and the digital terrain model. You can locate where the water should be arrested, which will help to conserve the water as well as soil. Then in water resources, the inventory of surface water body is very important. Where are the ponds and lakes are there, and how it is changing over the time. Then there is the groundwater explorations, also very important. In the geoscience, the technique has already been developed where the probable zones of the groundwater exist. Then snowmelt runoff analysis, the Himalayan region, the glaciers melt, and how it is melting, how that snout of the glaciers is retreating, those things can be analyzed easily using the remote sensing data. So this is the studies has been made in Vasca glaciers, and how that 1962 that snout is reducing, means it is coming up, it is going up and up. So that is the retreating of the glaciers, and it is related to the climate change. Groundwater prospect maps in the villages based on the zones where the water is available. It can be analyzed in the geoscience and geology, and also using the remote sensing data. It is just integrations of the old information to get this type of information. Now irrigation infrastructure is another area, in a command area where that irrigation right bank or left bank canal will be installed, how much area it will irrigate, all those things, the information can be collected from the satellite data. This each of the areas having its own advantages, and it takes a lot of efforts to do this type of analysis to come into the conclusion that the output of any project will benefit the user community and authorities who are involved in this type of activities. Then infrastructure is city planning, where the power line will go, where the sewage line will go. So all those things